Hi there, Year 8, and welcome to bright and early Monday morning first lesson science. Hooray! Today we're going to be learning about the camera and eyes, okay? And I absolutely love eyes. I used to work in medical research. I used to grow eye parts. I used to take them into surgery and watch them being grafted onto patients. It's fascinating, but I'm going to do my best not to go into that today because this is going on YouTube and yeah, some of you might not be that interested in eyes as well. I will be in the live lesson this morning in the chat if you wanted to ask any questions. Hopefully we're not going to derail the lesson too much though, because I'm not going to talk about eye research in this lesson, in this video. Okay, so first thing I want you to do it now. Write down which part of the body you think is the least likely to be donated after death. What do you think it is? Pause the video, write it down. Okay, unsurprisingly enough, it is the eye. Most people are a bit squeamish about eyes and they are the least likely organ to be donated after death. If you are interested in organ donation, do make sure that you're interested in eye donation as well, because it is needed. So, first thing we need to talk about is we've moved from sound and we've gone into light, because obviously that's what eyes do. And we need to talk about where light comes from. So what I want you to do is write down 3 places where you think light comes from. Pause the video, do it now. Okay, so light comes from lots of places. It comes from the sun, it comes from stars, it comes from the lights in your house. So I've got the lights on at the moment, but we can also get it from fire, from candles, from your phone screen, that's emitting light, your TV screen, your computer screen. As you're watching me speaking, it's all emitting light, from torches. So lots of different things where we can get light from, okay? And there's some key words that you need to know before we go too much further, okay? First one is transparent, okay? Now we all know what transparent means. It means you can see through it, okay? Glass in a window is transparent. You can see through it, okay? Next one is opaque, okay? And I've got a little toy cloud here. This toy cloud is opaque. You can't see through it, okay? If I got a slightly bigger toy, so I'm just going to pick up an aeroplane now, okay? And now I'm hiding behind the aeroplane. It is opaque, you can't see through it, you can't see me anymore. Here I am, don't worry, I didn't really go anywhere. Okay, and the final one we have to do is something called translucent. Okay, translucent. And translucent means it lets light through, but you actually can't see through it very much. So, okay, and a really good example is a sort of frosted bathroom window. But another good one is, I'm just going to turn the torch on this phone. Okay, so I've got a torch, a source of light, and if I put it underneath my skin, you can see that the light's coming through, but you can't see anything that's behind it. So skin is translucent. You can do this at home with a torch. You can get your torch, you can pop it up next to your skin, and you can check that your body is opaque. But if you're just only talking about skin, you can see it's letting the light through. It's translucent. Okay, let's turn the torch off. Okay, so the next thing we're going to do, we're going to just take a quick look in the book and look at structures of the eye. Okay, so this is what you need to know about the eye. Okay, what we've got at the top here is something called the cornea. Okay, and this is made of the same stuff your epidermis, your skin, is made of. Okay, so you've got loads of skin cells which are, don't forget, you can see through them, they're translucent, okay? So the light can go in through the skin cells, okay? And there's no blood vessels underneath here. So actually, instead of being translucent, they are transparent, because there's no blood vessels or anything like that underneath. So the light goes in through the cornea. Okay, and then it hits a jelly-like substance here. Okay, we're not too worried about what that's called. And that makes all of the light go through the pupil, which is this space here. Okay, you've got the iris at either sides. Okay, and the iris is the part of your eye which has the colour in. So if you've got a blue iris, you've got blue eyes. If you've got a brown iris, you've got brown eyes. Green iris, grey iris, green eyes, grey eyes. Okay. And then you've got these lovely muscles here, which are attached to a lens. Now, those of you that wear glasses will know that you have a lens in your glasses. Okay, and those lenses help you focus. Okay, so this lens focuses the image, and the image goes all the way to the back and it hits your retina there. Okay, now if you've ever taken a photo of someone and their eyes look red, what's happened is you've shone the flashlight and it's gone in past the cornea, through the humour here, through the lens, that's the vitreous humour, that's the aqueous humour, just in case you're wondering, through there, and it hits the back of the cornea and it's reflected back, just like with a mirror. And we're going to be talking a bit more about mirrors a bit later this week. And it's reflected back out, and that's why it looks red, because there's loads and loads of blood vessels around here, okay? And there's also cells called rods and cones, which pick up, either the rod picks up like the picture of what's going on, and the cones pick up the colours, okay? So we've got the cornea there, and the conjunctiva is all the white bit that's around it. Okay, you've got your iris and the pupil, which is the hole here. The lens with the muscles to make the lens get either long and thin or short and fat. And you've got the retina here. Okay, and then the retina has lots of nerve cells all the way through in this little black layer there. Lots of nerves which go down into the optic nerve and take it away to the brain so that we can see. Okay? And it focuses like this. Okay, so if you've got an object that's near, your muscles elongate, and so they squish the lens, and the image goes into the eye and is refracted, and we're going to do refraction later this week as well, and the image is formed on the retina. Okay, if it's far away, the muscles contract, the lens is pulled long and thin, the image goes in and is refracted back, and it forms on the retina. If you are short-sighted, the image doesn't form on the retina, it forms just beforehand. And if you are long-sighted, the image would form just behind the retina. So either which way, your lens isn't focusing it properly. The good news is, though, is that there are glasses, so you've got lots of ways to help them actually get the image correct. Okay. Now, interestingly enough, the image formed on the retina is actually upside down. So it goes in and comes out, and it actually flips the image and makes it upside down, and the brain sorts it the correct way out. There was a couple of hundred years ago now, there was an American man, can't remember what his name is now, and he invented some glasses which flipped the image over. And so he was seeing things the right way up, and he had a week of going round really struggling with what he was seeing until the brain went, oh, you're doing that. And then he was fine. And then he took the glasses off and everything looked like it was upside down again. Science is great. I love the fact that people do all these wonderful and weird experiments. So yeah, so this is what the eye looks like. If you want, you can pause the video and you can do this diagram and explain what each part does. You don't have to, but it might be useful if you want to do the Warwick Star task later. Okay. I've just seen, the only thing that I've seen that I didn't mention is this blind spot where the optic nerve comes in, because there's so many nerve bundles here. You don't have very much retina over the back, so you don't have any rods and cones. So this area of your eye is blind. Sorry, I forgot to mention that. Okay, so what we're going to do now is we are going to do a practical, and we are going to make a pinhole camera. So come this way.